Unveiling the animal kingdom. What is zoology? Zoology is the study of animals. It is a branch of biology, the science of life. Zoologists study all aspects of animal life. This includes their anatomy, physiology, behavior, and evolution. Animals are a diverse and fascinating group of organisms. They range in size from microscopic tardigrades to gigantic blue whales. Animals inhabit almost every corner of the planet, from the deepest oceans to the highest mountains. Zoology is a vital field of study for many reasons. It helps us understand the natural world around us. It also helps us appreciate the diversity of life on Earth. Zoology plays a crucial role in conservation efforts. By studying animals, we can learn how to protect them and their habitats. A revolutionary idea introducing Lamarckian evolution. Before Charles Darwin and his theory of natural selection, another scientist proposed a groundbreaking idea about how life changes over time. This scientist was Jean-Baptiste Lamarck, and his theory became known as Lamarckian evolution. Lamarck argued that life wasn't fixed. He believed that organisms could change over generations. His theory challenged the prevailing view that species were immutable, created in their present form. Lamarck's ideas, though flawed in some respects, represented a significant step forward in scientific thought. He paved the way for later evolutionary theories, including Darwin's. Use it or lose it. The core principles of Lamarckism. Lamarckian evolution rests on two fundamental principles. The first is the use and disuse principle. This principle states that the more an organism uses a particular organ or trait, the stronger and more developed it becomes. Conversely, traits that are not used gradually weaken and disappear. The second principle is the inheritance of acquired characteristics. Lamarck believed that organisms could pass on traits acquired during their lifetime to their offspring. This meant that changes an organism underwent due to its environment or behavior could be inherited by its progeny. Setting: the stage, the world before Darwin. To understand the impact of Lamarck's theory, we must travel back to the late 18th and early 19th centuries. This was a time before Darwin's theory of evolution gained widespread acceptance. The dominant belief then was that species were fixed and unchanging. This idea, known as fixity of species, was deeply ingrained in religious and scientific thought. Lamarck's ideas challenged this established view. He proposed that life on Earth had a history and that organisms were not static entities but rather in a constant state of flux. Section 5. A Tale of Two Theories, Lamarck versus Darwin. While both Lamarck and Darwin sought to explain how life evolves, their theories differed in crucial ways. Darwin's theory of natural selection hinges on the concept of variation within populations. Individuals with traits better suited to their environment are more likely to survive, reproduce, and pass on those advantageous traits. Lamarck, on the other hand, believed that organisms themselves could directly influence their evolutionary trajectory through their actions and experiences. He imagined a process of striving toward complexity, with organisms actively shaping their own destinies. Section 6. Stretching for the Sky. The giraffe's neck explained. The giraffe's long neck is a classic example used to illustrate Lamarckian evolution. According to Lamarck, giraffes' necks grew longer over generations as they stretched to reach leaves high in the trees. Each generation inherited slightly longer necks because their parents had stretched their necks throughout their lives. Over time, this process led to the impressive neck length we see in giraffes today. Section 7. Beyond the giraffe. More examples of Lamarckism in action. The giraffe's neck is not the only example used to support Lamarckian evolution. The strong legs of a blacksmith, developed through years of hammering, were thought to be passed down to their children. Similarly, the webbed feet of ducks were seen as a direct result of their ancestors paddling through water. While these examples seem intuitively appealing, they lack the rigorous evidence that supports Darwinian evolution. We now know that acquired characteristics, like a blacksmith's strong arms, are not directly encoded in the genes and therefore cannot be inherited. Section 8. A lasting legacy: Lamarck's impact on evolutionary thought. Although Lamarck's theory is not considered entirely accurate today, it played a crucial role in shaping the field of evolutionary biology. Lamarck challenged the prevailing dogma of his time. He opened the door to the possibility of species changing over time. His emphasis on the environment's role in shaping adaptations also proved influential. Even though his mechanism of inheritance was incorrect, his focus on adaptation prefigured Darwin's later work. Section 9. The future of zoology: Unraveling the mysteries of life. Zoology continues to be a dynamic and evolving field, constantly pushing the boundaries of our understanding of the animal kingdom. New technologies and research methods are providing unprecedented insights into animal behavior, genetics, and evolution. As we delve deeper into the intricate workings of animal life, we gain a greater appreciation for the interconnectedness of all living things. The study of zoology reminds us of the beauty and fragility of life on Earth and our responsibility to protect it.